Hello. Can you hear me?
We can hear you.
Okay, thank you. We are going to continue today with chapter 2. Essentially, I want you to learn how to use Excel to construct a frequency distribution table and also to draw graphs, which may be useful to you in the future. And so, in chapter 1, we learn how to collect data. Chapter 2, we are going to learn how to organize data. When you collect data, you have a bunch of information that are not organized and which may not reveal much information. So it is always good to organize it on a table that will list each data value and its frequency. For categorical data, you will list each category and the number associated with the category. So that is what we call a frequency distribution table. We are going to spend more time in what I will call a group frequency distribution table. We grouped numbers sometimes when there are too many into classes in order to reduce the number of category or values. This is an example of data collected from 30 students with their grades. The grades are listed here and we can decide to organize it on a frequency distribution table. One method will be to pick each grade, like starting with A, and put a column for tally and place a tally for A, then C and a tally. When we get back to A, we add another tally. You may be able to do that one. At the end, you count the number of tallies to determine the number of time each category occur. So that is what we have here. So I put tally. When I get to 4, I put a tally on top. So that makes each group, like here is 5. But you can have your own way of making your tallies to count the number of times each of these category will occur. If we have single number, for example, if it was grade point and we say A is 5, B is 4, C is 3, D is 2, and F is 0, or we could say A is 4, B is 3, C is 2, and D is 1, and F is 0, then we can still organize it using the same method. So essentially, you can make a frequency distribution table using either single numbers or category, like blood type, color, or as we had here, grade. This is an example of data collected that represents the number of people per household in 45 randomly selected family. So the researcher here listed the number of people in each family. So we can organize it on a frequency distribution table, as you can see here. So when we have numbers, it is always good to add to the table the relative frequency. The relative frequency is the number in the frequency divided by the total. It gives us actually the proportion of values of members that have that number. Then we also have cumulative frequency. Cumulative frequency is the number of values on or before the data that you have. For example, the cumulative frequency for 1 is 5. The cumulative frequency of 2 is the number of values that are less than or equals to 2. So we'll add to 5, 10, which is at the 2. Then we get 15. When we get to 3, the cumulative frequency for 3 is 15 plus 9. The cumulative frequency for 4 is 24 plus 9. So cumulative frequency is the total frequency before the data plus the frequency of the data. That helps us to easily determine the frequency of values that are less than or equal to the value that we have. So when numbers are too many, we can group them into classes. We may say, for example, that the first class is from 1 to 5, the second class is from 6 to 10, from 11 to 15. Those are classes. When we have a class like 1 to 5, 1 is the lower value of the class, the lowest value that can go into the class, and 5 is the highest value that can go into the class. In general, we are interested in how to make sure that we group our values in such a way that each data value can get into one class and only one class. That is, there is no overlapping. There is no ambiguity in determining which class a value is going into. We say that the classes are exhaustive. We want also to make sure that there is no gap between classes. That is, a number can always find a place to go. There is no gap. And we don't want too many classes. So in general, people think about at least 5, at most 15. In grouping data, you are going to be given the number of classes that is desired. So the first step in grouping data is to identify the highest and the lowest data value, which is going to help us to compute the range, which is highest data value minus lowest data value. If at any point you have a question, you should just stop me, just speak, and I will answer you. So we are going to use an example to illustrate each of these steps. So the width is very important. You obtain the width by dividing the range by the number of classes. Then you decide to round it up. In round it up, you think about the nature of the data values that you had. If your data values are all whole numbers, you will round it up to the next whole number. If your data values are decimals, you will look at how many decimals, at most how many decimals they have, and you round it up to that number of decimals. Then to construct the first class, you add the width to the lowest data value to get the upper value of the first class. The lower value of the first class is the smallest data value. The upper value is the lowest value or the lower class limit for the first class plus the width minus 1 unit. Important here is about the meaning of unit. When you deal with whole numbers, the unit is 1. Like you have numbers like 10, 20, you go 1, 2, 3, 4, you add 1 to get the next one. If you are going to 1 decimal, if the data value have at most 1 decimal, then your unit will be 0.1, because to account for all those values, you will not be going 1 by 1, you will be going by 0.1. That is 1, 1.1, 1.2, so etc. If you have 2 decimals, the unit will be 0.01, and so on. So once you have the class limit for the first class, the second class is obtained by adding the width to the lower limit of the first class and the upper limit of the first class to get the lower and upper limit of the second class, and so on. So if we have class limit, let's say 1 to 5, we can obtain the boundaries of those classes by subtracting half a unit from the first class and adding half a unit to the upper class, half to the lower class, half to the upper class. So you expand the class by half. Here you pay attention again to the nature of your data values. Make sure you know if they are of 1 unit, 0.1, 0.01, or 0.001, and so on. The class midpoint is the middle of the class. Is obtained by taking the average of the lower and upper value. It could be lower or upper class boundaries. Just take the average of the two numbers. It gives you the midpoint of the class. Let's look at an example here. In this example, a task force to encourage carpooling did a study of one-way commuting distances of workers in the downtown Dallas area. A random sample of 60 of these workers was taken. The commuting distances of the workers in the sample are given in the table. So, the first step for us to group this data into 6 classes will be to identify the highest data value and the lowest data value. So, one way to do it is by using Excel. Using Excel, you can list all these values on Excel. Let me get Excel. You may decide to use Excel at the same time with me. So I will enter all these data values in column 1. So if you have your computer or your textbook, this data is on example 2. And you can open your PowerPoint because you may not be able to see the data as I am using the screen to go on Excel. So I will spend about a minute or two to enter all the values in Excel. So I type each number and press enter. So I enter the 60 values. The reason why I'm using Excel is because it might be difficult for you to go through and be sure that you will easily identify the highest and the lowest data value. So with Excel, I am going to Excel, yes. I'm going to highlight the data. To 60. I'll right click to sort it from smallest to largest. So this tells me what is the highest data value and what is the lowest data value. So we can identify here that the lowest data value is 1 and the highest data value is 47. So we are going to go back to Excel. We will continue here with the PowerPoint. So we will compute the range is 47 minus 1, which is 46. We need 6 classes. We divide 46 by 6 to get the width 7.7. Because all the numbers were whole numbers, we will round it to the next whole number, which is 8. Actually, 46 divided by 6 is 7.66. If there were some decimal numbers, like 1 decimal, then we will round it up to 7.7. If there were some decimal up to 2 at most, we will round it up to 7.67. This is how you do round up for the width. But because all our numbers are whole numbers, we are not afraid that we will miss a decimal number. So we will round it up to 8. To construct the first class, we identify the lowest data value as the lower limit, the lower value of the first class, which is 1. Then we add the width 8 and subtract 1 as 1 unit to get back to 8. So the class limit, the first class limit is 1 to 8. So we can now construct a group frequency distribution for the data that we had. So first class is 1 to 8. For the second class, you add the width, which was 8, to the lower and upper value to get 9 to 16, and so on. Next, you make a class boundaries by subtracting half the unit, which is 0.5, from 1 and add it to 8 to get 0.5, 8.5. When we do so, you have the class boundaries that we can have here. These are the class boundaries. They are just a shift to the left and right by half of the class limit. Then the class midpoint is obtained by adding the two numbers, either on class limit or class boundaries, and divide it by 2. So we get the class midpoint. To get the frequency, we need to do some other type of work. To get the frequency, we are going to use Excel that will help us to count the number of values that are between 0.5 and 8.5, and so on. So I'm going to go back to Excel, and in Excel, I'm going to enter the upper class boundaries alone, just the upper class boundaries. So going back to Excel, I will go to column B and enter 8.5 is the upper class boundary for the first class, 16.5, just keep adding 8, 24.5, so these are the upper class boundaries, which I will need to determine the number of values that are between them and before. So having this, I hope you are all listening to me. I will advise you, I want to understand that you are following me with your own laptop and with your own Excel, because I want to do something now, which I wish all of you should learn how to do. So pay more attention. If you were not, you will click on data. As you click on data, you will see data analysis here. Is anyone seeing data analysis? Or is anyone not seeing data analysis? Just let me know if you can or cannot see data analysis. This is just for me to know if anybody is doing it with me. Data analysis is a very important tool that you will need throughout the class. You may not have it. I want to know if you have it. If you don't, I want to help you to get it.
I don't see it on my screen.
Good. I wanted to hear somebody say that I don't see it so that I should show you. Otherwise, there will be no need to do so. Okay, now, if you have Excel, please follow my instructions so as to get data analysis on your Excel. If you are behind, just let me know. So go to File, you go to File, and then you will click on Options. From Option, you will see this box that opens. You will click on Add-ins. So from Add-ins, you will see Manage Excel Add-ins here. You click Go. Now, if you look at this box, you will not have these two boxes checked. So make sure you check Analysis Toolpack and Analysis Toolpack VBA. Just check those two boxes. And then click OK. You need to do that once and you will always be having it. As I say, it's a tool that we will need along the line. In everything we will be doing on statistics using Excel, we need data analysis. So now, if you forget, I'm recording this, I will put it on Canvas. You can always come back to check it. From data analysis, I'm going to click on data analysis here and then go to histogram. This function is going to help us to make a histogram, which is a graph, a statistical graph, but most importantly, it is going to help us to get the frequency for each class. So the input range will be all to highlight all the data values. The 60, you can just type A1 to A60. The bin is the B1 to B6. Those are the places where we have the upper class boundaries. Now I want the results to show up on the same sheet. So I will click here. If I want to have a histogram, I will click chart out here. Then I will click OK. So these are the frequencies for our data set. The frequency of the first class is 14, second class is 21, and so on. So we have the frequency. I will come back to the histogram later. So this is the frequency distribution table that we have here. It is difficult to make a frequency with tallies because if you want to do it manually and you have too many numbers, you can forget some. Using Excel will make things more accurate for you. Otherwise, you can still use the tally as you see me doing here. You can still use the tally as we did for categorical data. When you read a data value, if you read 13, for example, 13 will go to 9 to 16. You will put a tally here. And if you go to the next value is 47, you will look for the class containing 47 is the last class. You will put a tally here if you want to do it manually. but I believe it's faster and easier and more accurate to use Excel. We can also add to, these are the steps in using Excel, which we just went through. So now I spoke to you about graphs. Once we have our frequency distribution table, either for qualitative data, like the grade, the blood type, the color, those are qualitative. You can make a graph with those data. If you have a on group frequency distribution, that is when you have not put them into classes, you use them as single value, add and subtract 0.5 or the unit if there are decimal values, half of the unit, to put them into a form of class that contain just that single value. And you can use it, the same method, to get a histogram. So now to construct those graphs, we will start with the histogram, which we already have. A histogram will present data on a rectangular coordinate system. This is a histogram where each bar is proportional to the frequency of the class. I can complete this one by writing here 0.5. Here is 8.5. Here is 16.5. I'm just making up the class boundaries back. Here is 24.5. 32.5. 40.5. So we can reduce the gaps between these bars by clicking on any bar, right click, and format data series. Here we want to reduce the gap width. If you don't want it too close, you can separate them as you wish. For example, this is a frequency distribution. This is a histogram. Remember I told you to get this histogram, just click chart out on Excel. But we are going to learn how to do each of these graphs if you are given a frequency distribution table. This histogram function of Excel was very useful, mostly in getting the frequencies. But if you already have your frequency distribution table, you can still use Excel without going through data analysis to make graphs. That is what we are going to do next. We will use Excel to make a histogram. We will use Excel to make an OGIF, which is a cumulative frequency graph. So I've gone through all this already. That's what we just did. So this is the histogram that we made. I will show you how to make a histogram here, how to make a histogram. I will make a histogram again now by using class boundaries or class limit, whichever one you prefer. The steps are here, but I will go back to Excel to do another one. First, I want you to remember that what I did here on this Excel was making a histogram at the same time as I am getting the frequencies. What I want to show you now is, in case somebody gives you a frequency distribution table, how will you make a histogram, a frequency polygon, if you have a frequency distribution table? So on column A, I am going to enter the class boundaries or the class limits. I will choose the class boundaries. I use a different sheet here. So the work we did was on sheet 1. So I am going to sheet 2 because I want to do it differently. So the class boundaries are 0.5 to 8.5, 8.5, so these are the class boundaries. I could as well put 1 to 8, 9 to 16, 17 to, and so on. Just the class limit. 17 to 24, 25 to 32. Each of those could be used for this, but people prefer class boundaries for histogram. Now on column B, I will enter the frequency. 14, 21, 11, 6, 4, 4. So having this, I will highlight. I'll highlight all the graph. I will do the same if at the place of class boundaries, I was having potato chips, pretzels, orange, mangoes, or whatever I have. And then on column B, I put the number associated with to decide which graph I want to use. So now I go to insert and I choose the graph. We are starting with a histogram. This is a histogram, then that gives us a histogram. So as I told you, the first work we did on sheet 1 was mainly because we did not have the frequency. That's why we did so many steps to get the frequency. But in case you already have your frequencies and your class boundaries, you can just use the graph, the insert graph. So you can reduce the gap using the same thing I did before. Click on any bar, right click, format, and then reduce the gap. Next, we want to look at some other type of graphs. So the histogram is good because it can help us to have an idea of the nature of the distribution. We are going to look at the shapes of graph later, and histograms can help us to determine the nature of the distribution by looking at the shape of the histogram. So these are some type of shapes. A histogram of this type, the first one is a mount-shaped or symmetrical histogram. A histogram, as in B, is a uniform distribution. A histogram, as in C, is skewed, either to the left, like in C, or to the right on the second one. The last graph is a bimodal histogram. So if you have a histogram, I can ask you what is the shape or what is the nature of the distribution. You will generally have either a symmetric, a skewed to the left or skewed to the right. But know that there are more other type of graph, but these are some graphs that are typical of what we get into in research. So a cumulative frequency is the addition of the frequency, as I explained to you, to the point where you are. For group frequency distribution, the cumulative frequency of a class is the number of values that are less than the upper class boundary of that class. So we can make a cumulative distribution graph using Excel as well. So it is called an ogive. It uses the cumulative distribution or the cumulative frequency together with the upper class boundaries. To use Excel to construct it, let me go back to Excel and let's see how we can make a cumulative frequency. So I will start anywhere here so that we have this, the values are before us. So I will enter the upper class boundary. I will consider 0.5 as the upper boundary of all the values that are not listed. So I will start with 0.5. Then I will go to 8.5, 16.5, 24.5. These are the upper boundaries, which I would just want to use to make my ogive. Now, as cumulative frequency, I will write the number of values that are less than or equal to the point that I have. At 0.5, there is no value before it, so I put 0. At 8.5, I have 14. At 16.5, I'm going to add 14 to 21. That will give 35. The cumulative for 24.5 will be 45 plus 35, I'm sorry, plus 11, which is 46. Then 46 plus 6, 52. 52 plus 4, 56. And 56 plus 4, 60. At the end, you should have the total sample size. So we are going to use the upper class boundary and the cumulative frequency. So what I will do here, I will highlight and then go to insert, choose the point here, and get the frequency polygon. Again, let me show you again. I highlight the upper class boundary, including the lower class boundary of the first class, which is the upper boundary of all the values that are not listed and below that. so that I should get a point at the beginning here. That's the reason why I'm putting the lower class boundary. Now I highlight, go to insert, and when I am on insert, I will choose this line segments. Of all these graph, I won't see any, so I will click more graph, and I see this one is the best to represent it. So because I want those points, I can come here and click anywhere to get the point, and then click OK. So it has covered our histogram. So this graph is called an ogive or cumulative graph. This graph is called an ogive or a cumulative graph. If you have your frequency distribution table, you can use your pen and paper to make this graph. Just put here the class boundaries, but sometimes when you have 1,000 graph, 1,000 data values, it will be difficult for you to just do it manually. That's why it is good for you to learn how to use Excel. Most of the graphs that we are going to be doing, we will follow the same procedure, listing the data values and the numbers associated with it. There are many other types of graph. The Pareto chart is one of those graphs that are used to represent qualitative categorical data. It looks like a histogram with the difference that the bars are arranged in descending order, meaning that once you have the frequency of your category, you rearrange them by order of frequency before using the Excel insert method. You can see here how to make a histogram. I'm going to do a histogram and circle graph together. So these are some data values listing the blood type of 28 students. We are going to use it to make both a Pareto chart and a circle graph. So I'm going to move to circle graph. In a circle graph, you represent data on a circle like a pie, in which each segment or sectors is proportional to the frequency of the category. So let's use this frequency distribution table to make this graph. We have blood type A, B, and O. So I'm going back to Excel. And I will take another sheet. Then we have A, B, AB, O. The frequency for A is 8, for B is 6, for AB is 4, and for O is 10. So I have my data here. It could be anything. It could be freshman, sophomore, junior, faculty, non-teaching staff. It could be any category that you may have. You want to make a Pareto chart. Remember, for a circle graph, you can use it as it is. But for Pareto chart, you want to arrange it in descending order. So I will highlight just the numbers, right click on my Excel, and sort it in descending, largest to smallest, descending, largest to smallest. So this happened because it will rearrange my category as well. So I click OK. So if you only have 4 categories as what I had here, I could just know that O comes first, A, B, and AB. But if I have 100 category, I may not be able to do that. That's why I am teaching you how to use Excel to do that. So I have arranged my category in a descending order of frequency. I cannot highlight it because I want a Pareto chart that looks like a histogram. And this is the Pareto chart. I can reduce the gap by clicking on any of the bars. Right click and then reduce something like this. So this is a Pareto chart. Now to make a circle graph, highlight, you don't need to order it for circle. Highlight it and go to insert and then click the circle. We can choose this one. And then you will have many other options here. You can decide, I can decide to choose this one. That gives me a circle graph. You can enter the title by clicking here. For all the graph, you can always enter the title here. Circle graph or pie graph. So it's covering. I can just, you can copy and paste on your Word if you are doing your project or some homework that require making a graph. Another type of graph is a time series graph. In a time series graph, you represent data that are occurring over a sequence of time. You might want to know the temperature of an object within the next 5 hours. After 1 hour, you take the temperature. After 2 hours, you take the temperature. The graph that will represent it will be represented by a time series graph. You might want to know the number of infection of a certain disease within a number of days or number of weeks. Week 1, week 2, week 3, you keep counting and you make a time series graph. So when data occur over a sequence of time, a series of time, we call it a time series graph. To make a time series graph, you use a line segment graph. This is an example of time series graph. You will use a line segment graph to make this. We can take a minute to do it. I will not do for all, I will just do few of it for some few of the values, so to save time. I go back to Excel. I will open another sheet for that new data. So I have, suppose you have been in a walking or jogging exercise program for 20 weeks, and for each week, you have recorded the distance you covered in 30 minutes. Your data is below. Because these values are 1 to 20, I don't need to write 1 to 20. I will just need to write the distance because by default, 1, 2, 3, 4, 5 is the number that goes on the x-axis. So I will have 1.5, 1.4. If it was January, February, March, or week 1, week 2, week 3, I will enter it in column A and enter the distance in column B. If you are having your Excel, you will learn better by practicing at the same time with me. I have the 20 values on Excel. Making sure you are seeing it. Then I highlight it. And I will go to insert and choose a line segment graph, because that is actually a line segment. And this is good for it. So this is a line segment graph for the distance you run a joke with it for 20 weeks. So it represents the data value on a graph. So on my PowerPoint, I am saying the same thing, the audio PowerPoint that you have. I just decided to make this live for the beginning. And if, as I told you, if you feel it's better, we can continue, but you can also go over an audio PowerPoint, which I have recorded alone. When I record alone, I go faster because I know nobody is listening to me. But because you are listening to me, I'm trying to go slower, and I'm expecting you to ask questions when you have one. So the last type of graph that or representation is the stem and leaf display. The stem and leaf display is a display of data by dividing the values into two parts, one which is called a stem and the other one the leaf. Generally, when we have 2 digits, it's much easier. We take the first digit as the stem and the second digit as the leaf. In doing so, we observe the nature of the data. It goes here from a 1 digit to about maybe the highest. Here, I will look at the highest. So far, I am seeing 45, 47. So the highest here is 4. So there was a 51 there. There was a 51. This is 51. So because it goes to 51, my stem will be 0 to 5. And then behind each stem, I'm going to write the leaf. That is a number. 0 is for 1 digit. So if I read a number 30, I'm going to have stem 3 and leaf 0. I go and put behind 3, I write 0. The next number is 27. I'm going to go behind the stem of 2, I will write 7. This is the stem of 2, then I write 7, and so on. Then here you rearrange it, you arrange it in order. So that's it for chapter 2. Anybody has a question? I am planning to do something like this again on Tuesday. If this time is good, we have about 9 students, is good, for chapter 3. So I will do this again for chapter 3. And then from there, it will be like as needed. If you feel like you want us to have another one, then you just send me an email. So, but if you have question on your homework, as I told you before, let me know. We can arrange for a discussion on homework as well. If you like, we can do all your homework together. If I do it for one student, I will not have to do it for another. I will announce if the first student that tells me I want us to have a homework session, I will announce it to the class the day we are going to have it. And all those who are willing to participate should participate. And if you are there, just remind me to click record so that we record it so that you can see it. Because sometimes I forget to click that link. Any question? Okay, if there's no question, you can always send me an email if you have a question. Okay, have a nice evening.
Thank you. You too.
Thank you.
Welcome, thank you.